In this exercise, you're going to be using a GIS map to explore the distribution of volcanoes around our planet. Now, before we get into that in detail, I want to take a look at a couple of things in general about describing distributions. This is something that we do a lot in geography, and it's useful for you to have a little bit of a background knowledge as to what that means. So we can define in the geographical sense a distribution is this. It's describing how something is spread out across an area. More specifically, particularly when it comes to your GCSE, it's saying where it is and where it isn't. So let's have a look at this map of population distribution in Australia. What would you say about the distribution there? Where is it and where is the population not as densely distributed? Have we think about that? Okay, maybe whenever you were starting to look at this population distribution, you started to look at some words like this to describe where they were and where they aren't. And there's some types that this is not a complete list, but it shows you some of the things that you could be looking at. The regular distribution, this is clearly not a regular distribution. I wonder, do you see it being concentrated in places and spread out elsewhere? It certainly seems to be concentrated around the coast and very, very few in the centre of Australia. And what about the patterns that you begin to see and what shapes? Patterns that could include linear, perhaps they're linear here, forming a line in other words, or circular and those kinds of things. But what we discover as we start to take a look at describing distributions is that these patterns that we see, these types of distribution, very often reflect other factors which influence them. So have a think for a moment. What do you think is, or what do you think are some of the factors that might influence where people live in Australia? Okay, I wonder, did you think about the climate? This is a map showing some of the different climate areas in Australia. Have we look at that? Can you see a relationship between them? Pause the video and have a little think. Okay, I'm hoping that you did, because what you should have seen is that this distribution of people here, they are very much concentrated on the east and the southeast especially, and down here in the southwest. They're concentrated in this linear pattern around about the coastlines and up around about here as well. There are very, very few in the centre. And we would take a look here at what we find. This is a temperate climate. It's actually quite similar to what we find in the United Kingdom, that kind of thing. And then we're up into here into subtropical. Over here we're temperate, and you've got more people there as well. But right here in the centre, where you have very few people, you have the desert. So not surprisingly, people are tending to live where the conditions are more favourable for them. So those are some of the underlying factors that can influence them. So distribution, where it is and where it isn't. There are different types you can see, and these very often can reflect underlying factors. Let's have a little exploration of this. What's the distribution here and what's explaining it? Have a look at that slide. Pause it here for a moment and see what you think. What's the distribution and what's explaining it? Okay, so maybe you're seeing it being concentrated here and little clusters here as well, and more spread out over here, and there's none around the edge at all. Now, I wonder, can you have any idea what might be explaining that? Well, it's tough whenever you just see this, but as I've said above here, there are very often other factors which influence these distributions. And the good thing is when you're using a GIS map that you can actually turn on layers. You can add on more layers that help you to see what other factors are at work. So let me turn on a layer for you here on this map. And I've turned on a layer which reveals where the stadiums are in this area. Now, I wonder, does that give you a clue as to what you're looking at? Well, let me turn on another layer. I think this one should definitely give you a clue. This is a layer of what these dots represent, and they are football fans, City and United. So what we seem to have here is a football stadium with the fans sitting around the edge. There's the pitch in the middle and the visiting fans concentrated in one part of the stadium. In the town you have got all of the rest of the fans from the local area, and they seem to be spread out quite randomly across the area, but you have these little clusters. So what do you think these clusters represent? Any thoughts? Any ideas? Well, why don't we turn on another layer and find out? They're the pubs. Because if you're not watching the football stadium or football in the stadium itself, you might go to the pubs with your mates and watch them there. So what do you reckon is this bit around the side? Why is there nobody here? Let's turn on our final layer, and that's the edge of the settlement. So you don't have as many fans outside of that. So what we've done here is turned on a series of layers that have allowed us to describe this distribution, and they've allowed us to find these other factors that influence that distribution as well. And in this task, we're going to go on and do exactly the same, describing the global distribution of volcanoes. We're going to take a look at those little dots. You can see they're different colors representing different types of volcanoes, and they're in different locations, and we're going to use this information to help us to explain it. Okay, so first thing you need to do, having got that introduction out of the way, is to open up the GIS map on your copy of the slides. Click on it and it will open up this map here for you, and you'll get to see this now, just so that you can navigate your way around a little bit here. And this side panel is the panel that you're going to be using to turn layers on and off. And if I just show you that, you can see that that turns the layers on and off for the world volcanoes, very similar to what I've just done in that Google Slides. But about the key or legend, this is the tab here that shows these for you. You can see different colors of volcanoes or different types of volcanoes. And you zoom in a little bit further, you'll be able to see those shown down here, these little clusters and so forth around about this area. But let's zoom out again. And I will come back in here and I'll show you what you've got to do as we move through. So for this, you're going to be starting off by describing the overall distribution. So you're turning on the layer tectonic plate boundaries. Okay, so that's this layer here. And what we're going to try and do is to describe the location of these volcanoes in relation to the tectonic plate boundaries. So let me turn this on first of all. And there's the plate boundaries have appeared in the map. And again, if you want to go into the legend here to see the different types of plate boundaries, you can do that. So you've turned that on. Now, the next thing I'm going to be talking about is this. To what extent is this statement true? The world's volcanoes are found along plate margins. Now, remember, we're looking at the extent to which they are found there and the extent to which they are not. So you need to balance this up. You will find some that are on plate margins, some that aren't. But what I want you to do is to balance this up. Is this statement rarely true, sometimes true, or mostly true? Now, there's a little bit of a clue. Look at the size of the boxes. But I don't want you just to assume that. Let's go in and have a bit of a look. And because there's a GIS map, you can just drag this around. You can zoom in. You can have a little bit of a look at all these volcanoes here alongside this plate margin and so forth. So I need you to name some of the margins and the continents or oceans that are found there. So let me give you an example. If we went here to the Western Pacific, and you have, let's go into the legend, a convergent that's coming together plate boundary, which is our destructive plate boundary. You have this convergent or destructive boundary there, and you've got all of these volcanoes beside it. So what you can do is refer to this continent or ocean here and a range of these different locations. And then you need to find somewhere on the map where you've got volcanoes where you don't have plate margins. There are a few of these, and go and find those and get some examples as well. And then fill that in at the bottom. Okay, so the next thing that you're going to be doing is a slightly more refined investigation of this, because we're going to now look at different types of volcanoes. So basically what we're going to be looking at here are composite volcanoes are normally found at what type of plate margin. Here are a few of the things that you need to do in order to set this up. The instructions are all here, but I'll just show you in the video. So we're back into the content layer and the world volcanoes, and we're going to use the filter, which is this little symbol here. If you hover over it, that name will appear. You just click on it, and it'll allow you to choose things from a drop-down menu here. So you just click on that, and we're going to go for simple type is, in the first case is going to be composite, but you can see you can choose shield or caldera as well here, but we're just going to do composite, and then you apply filter. Now what will happen is the volcanoes will disappear from the map, filter will be applied, and now only the composite ones are left, those yellows, right? So that's how you apply the filter, and that allows you to see just those composite volcanoes. So come back into the task here. That shows you how to do all of that. Look carefully at what type of plate margin are composite volcanoes usually found. And again, quote a range of examples to help you with that. So there's your key. Look at these. Remember, convergent is coming together. That's your destructive. Divergent is moving apart. That's your constructive. Transform is moving alongside each other. That's your conservative plate margin. So you need to go through here and see those yellow dots. Which one are they mostly at? Again, zoom in, get some examples, name some continents, some oceans, and things like that. Okay, the next one, you're going to change the filter, and you're going to do something very similar this time for the distribution of shield volcanoes. So you come back here, there's your filter again, and we're going to edit the filter. Simple type, drop down menu is shield, and then we're going to click apply filter. Simple type, drop down menu, shield, apply filter, and there we go. There's the red for the shield volcanoes. So same kind of question. They're normally found where, and include some examples. Okay, so we've looked at the overall distribution, and then we've looked at the distribution of different types of volcanoes and how they relate to different types of plate margins. The final thing we're going to do with this GIS map is go in and explore some particular examples of volcanoes, because you're in control of scale here, so why not go and have a little bit of a look around the world. The first thing I want you to do is to change the base map and to turn off one of the layers. So I'll show you how to do that. Okay, we're up here to change the base map. Select that, and this time we're going to go to imagery, and I'm going to turn off this layer of ocean base, and this makes this look a little bit more like Google Earth for you. Now, to navigate around, then what you're going to do is to use a series of bookmarks. I'll show you where to find those in a moment, and to visit the following locations, and then you're going to fill this in here. I've done one for you here because it's maybe a bit hard for you to know, but you're basically going through and getting this data and filling these in. Okay, so bookmarks, first of all, I'll show you where they're found. Let's go back into the GIS map, and there it is up here. There's your bookmarks. You just click on there, and that's going to guide you through your different bookmarks and the different locations that you're going to be going to. So basically what I want you to do is to go through those bookmarks, those locations one by one, and I want you then to go, so we'll go to the first one here. Let's go to Mount Rainier. So the first thing is, what country is it in? Now you might need to zoom out a little bit in order to find the country that it's in. So zoom, 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 zoom. Use your little mouse wheel. Oh, look, we're in United States of America. Let's go back into it again, Mount Rainier. And we've got our world volcanoes. Now what I need to do actually is to remove this filter. That's an important step. So remember, I'll just show you again where you get that little filter there. Remove the filter, and there is your symbol. Now it's a wee bit hard to see, but I'm hoping you can see it there, because when you click on that little symbol for the volcano, it gives you a lot of information about it. Okay, so the simple type here is composite. You've got the elevation of it here, and that's the kind of thing that allows you to fill that in, the height and the simple type, right? What type of plate margin is nearest to it? You've got your boundaries on, so you'll just have to zoom out a little bit until you see the first of the plate margins appearing. Oh, there it is. If you don't remember what that is, we're coming in here. It's convergent. Remember, we're not going to refer to it as convergent. We're going to call it destructive. Divergent is constructive. Transform is conservative. And the nearest one is your convergent or destructive margin. You're going to fill that in, your destructive margin. And then you can get the height from the little symbol you click, and then the diameter. So let's go in and have a look at how you get the diameter of this. If you remember, composite volcanoes should be relatively narrow and steep-sided. So we've got the height here. We can click on that there. That's for elevation. So 4,392 meters, right? What about the diameter? How are you going to get that? Well, for that one, you come up here to your measure tool. It's just beside your bookmark tool. You're going to click on it. There's your distance. You're going to click once and then drag across. Click again. In fact, double click, and that gives you your diameter 17.5. So you'll fill that information in on Mount Rainier. That gives you your diameter. And then move on to the rest of them. Once you've completed that whole table, then we're going to go into a very close look at one final volcano. This is a volcano in the Philippines called Mount Pinatubo that erupted catastrophically in 1991. And you're going to be taking a look at some of the things that came out of that volcano, some of the things out of the composite volcano, the ash and the pyroclastic flows. So what you will be doing here is going to this bookmark of Mount Pinatubo, and if you turn on this layer here of Pinatubo ash and pyroclastic flows, again, if you need a key, there's the key here. So the orange is the crater, the grey is the ash cloud, and these reddy brown colours are your pyroclastic flows. And you can see that. And again, you can zoom in, have a look. You can turn that layer off and on. You can go down and visit the crater if you like, and just get a real feel for this volcano. So let me just go back to the bookmark to get us orientated right, and we'll turn this layer on. Okay. So having looked at these distribution patterns, I'm going to give you a question that is the most tricky one right at the end here, because the question here is asking you to contrast the distribution pattern of the ash and the pyroclastic flows in the 1991 eruption. Contrast them. The patterns aren't quite the same. So to help you with that, remember where we started way back here, we talked about things like the patterns could be linear, they could be circular, things like that. So I want you to be having a look here and describe that in as much detail as possible. And also what I want you to be doing is to referring to compass directions, north, south, southwest, northeast, that kind of thing. Now to collect some information here, we can come back to the measure tool. So you can get a sense from the crater out towards the edge of how far they go. You can add those on. So you can compare and contrast the way in which they move. But you can also use the area tool if you like. Now, I'm going to demo this for you just with the crater. You can collect all sorts of information from this. So what's the area of the crater? Well, the measure tool and this area tool, you just you select it, click, and then just keep clicking around the edge. And as you click around the edge, you'll see that you start to select an area. And as you start to select this area, you can see the area that is affected by this. So you can get something of the area of that as well. That's 4.7 square kilometers is the area of the crater. So you can use the measure tool and the area tool to bring out as much information and detail as possible for that one. Now, I've given you a few tips. I hope that will help you with that very last question. But this is a question that will really allow you to shine. Having done the earlier work, this will really allow you to go that bit further, and it'll show me the extent to which you've really picked up the point of this exercise, which is really to help you to learn how to describe those distributions in as much detail as you possibly can. So just very briefly to recap on what you've picked up from this, the distributions and describing how it's spread out, where things are and where they're not. There are types of them. You're beginning to pick up, I hope, a sense of the ways in which you can describe these things. And we're also noticing that there are reasons that underpin them. There are reasons why these distributions occur the way that they do. And what we've had a chance then to do is to take a look at this global distribution of volcanoes, I should say. You've got those related to your plate boundaries. you discovered that most of them are occurring on or near plate boundaries, but not all. You've got some like this in the center of the Pacific Ocean. You've had a chance to relate them to the plate margins, and you've had a chance then to go and really develop your sense of space and of place by going and exploring a whole bunch of these different volcanoes together, all through that wonderful power of that GIS map.